I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for consistently posting excellent comments and suggestions. And because of you, since last 15 years, we had been busy uploading videos almost daily. In today's video, I'm going to discuss quadratic functions, key characteristics, and we'll analyze these characteristics to see how we can sketch a graph. This video is going to be a bit long since we are covering all the topics within quadratic functions related to the vertex form of the equation. We'll identify the key characteristics. We'll make a rough sketch to begin with, describe steps to graph. We'll graph it using two different methods. One is using table of values, which is very common, normally done at schools. And the other method will be my own method, which I call step method. In table of values, you have to calculate all the values, put them there on the graph and connect them with the line of best fit, which is a parabola. And the step method, we already know that it is a parabola, so we have a very unique process in which no calculations are required, right? So let me write down here, no calculations. What I mean is, you don't have to substitute the values of x and create a table of values to sketch the graph. So once we have the graph with us, then we'll again analyze the graph, label it properly and understand what we've got. I think that will give you a good foundation for graph of any quadratic function, especially if the equation is given in the vertex form. We also have a video which will have similar description for the parabola when the equation is given in other forms like factored form or standard form. Okay. The key parameters which we are going to discuss are domain, range, direction of opening, axis of symmetry, vertex, maximum or minimum. It really depends on opening, right? Decreasing interval, increasing interval, number of real roots, y-intercept, x-intercept, and steps method for graphing. So, number of real roots is another very critical part which 90% students do not understand from the given equation. So, as you can see, at almost it is packed with information which you really need. So, spend some time understanding these concepts. In case you really want to learn from me, you can send an email on the address given or contact me on the website. As you know, most of our students have been on top of their classes. They have the confidence and they succeed.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel.
Now, let's look into this quadratic function. Y equals to 2, x minus 3 whole square minus 8, and we'll take up these parameters one by one. Let's begin with the key parameters, which are domain, range, and direction of opening. So, for any parabola, in this case, we have y equals to 2 times x minus 3 whole square minus 8. So it's a good idea to make a rough sketch. I'm telling you the practical way of approaching any problem when it especially relates to graphing type of thing. Make a rough sketch. So we know this is a parabola, and in parabola, since 2 is the leading coefficient, which is positive, the direction of opening is up, right? So we can just sketch one. Arrows at the end indicate that end behavior. So as x approaches positive infinity or negative infinity, y value also approaches positive infinity, right? Now this is the end behavior which normally teachers will talk about in higher grades and not in the very beginning. Like grade 9, grade 10 students normally do not talk about this. Okay. This point is the very first point to begin with. It's called the vertex, as you know. And the coordinates of the vertex are h and k, or these values. What makes this x minus 3 0? And that is at 3. When this is 0, then the value of y is minus 8. Makes sense? So we got the vertex from here. So we'll fill in vertex, which is 3, comma minus 8. Do you see? I'm not filling the information in a particular order. I'm going with the flow. Well, you can always see that all quadratic functions have no restrictions, and the domain always is that x belongs to real numbers. Right. So this symbol, when I say x belongs to real numbers, how to read this? Read as this. X belongs to the set of real numbers. So the numbers represented on the number line are all real numbers. So x-axis, all real numbers. You get the idea, right? It includes rational and irrational numbers. All the numbers on the number line. Perfect. So always by default, for any quadratic function like this, or any quadratic function, it is continuous, smooth curve. So x belongs to real number is common, so you could blindly write this. Now range. Range, you can see, since it opens up and the value which you're looking at is absolute minimum. So when it opens up, we can say that we have absolute minimum value. Which is minus 8. So it makes sense when we write that the range is y greater than equal to minus 8. Now in brackets, I've written values of y as range. So that is what it is, right? So initially, when you begin with, sometimes it is confusing. Well, where y is also belonging to all real numbers. Perfect. So strictly speaking, I should have written this in set form. So that is the interval form, okay? So we say y belongs to real numbers so that y is greater than equal to minus 8. Perfect. So I've used two different notations. Y greater than equal to minus 8 is the interval notation, and the other one is the set notation. Axis of symmetry. So every parabola has an axis of symmetry, and in this case, of course, it is at the vertex. So axis of symmetry, the line which I am drawing now, will always pass through the vertex, and we are actually looking at the x value, which in this case is 3. And therefore, the axis of symmetry is x equals to 3. Students normally write just 3. 3 has no value in itself. You have to write the equation of this vertical line, the axis of symmetry, which is x equals to 3. Get the idea? And we already identified that the graph has absolute minimum value. So it is absolute minimum, right? Which we are having, and the absolute minimum value is y equals to minus 8. Makes sense? Extremely important information which you can directly read from the equation itself. You see, I did nothing. So from the equation, I know domain is all real numbers. Y is greater than or equal to this, since 2 is a leading coefficient, right? So we say leading coefficient is positive. Is positive. And therefore, the graph goes up. Do you see that? And of course, when it goes up, we do get a minimum value. Makes sense? So I hope this part is absolutely clear. Now, I'm not giving you 20 examples, and therefore, I'm spending time here for you to understand how could you do 100 more using these concepts, right? Are you there with me? Perfect. Anyway, if you really want to learn from me, you can always send an email on the address given, or contact us on the email, the website. Now let's get into the other parameters. 6 of them we have done. 3 more in this particular case. So it's a good idea to keep that graph on the side, which we just drawn with a lot of information. So that's why I've designed my page in a fashion that makes sense. So we identified from the equation that the vertex is at 3 minus 8. So that's one of the most important key point, and that gives you the purpose of this equation, which is called vertex form. So we are analyzing the vertex form of the equation of a parabola. The shape, the curve is called parabola, right? Decreasing interval, increasing interval, and number of real roots. Very critical question. Now see, whenever you see a graph, so how do you see a graph? From left to right. Put it big and bold. From left to right means you have to see as if you're coming from this side. So when you're coming from this side, what happens? Well, you hit this graph and then you go down. Do you see that? So this is the decreasing interval. You get the idea. So, and it decreases till which value? Till this vertex, which is at 3. So therefore, we could write the decreasing interval from minus infinity to 3. Makes sense? Because the domain is from minus infinity to plus infinity. And now, what happens after 3? Well, after 3, the graph starts increasing. And therefore, we have increasing interval from 3 to infinity. Makes sense? Now, when I write interval notation with these brackets, it means that we are not including 3 in either case. And of course, infinity cannot be included, right? So is that clear to you? Now the key question, which is one of the most difficult questions to answer, is number of roots. I have really not sketched the graph. Did I? No. It's a very rough sketch which has given me the vertex. But there is one thing very clear about it, and that is the range is greater than minus 8, right? So we know that the range is y values greater than or equal to minus 8. So that means we are below the x-axis, right? So if I have to draw the x-axis somewhere, it will be like this, right? This is my x-axis. And since the y value is minus 8, it's much below, x being at 3 at this particular point, my y-axis will be somewhere here. You can see that. And clearly, there are two x-intercepts for the graph. And number of roots will be 2. So I could do it by visualizing. So visualize. That is one way, of course. Another thing which I will say straight away from the equation also, you can give how. How from the equation? Let's see that. Do you see this minus and this being plus? So if we have opposite sign, in that case, we have two roots. So opposite signs. Makes sense. If you are below the x-axis, that is minus value, you have to go up to strike at the x-axis. And if you do that from the symmetry, you will hit it at 2 points. You get the idea. If this 2 was minus 2, I would have been going down, not touching the x-axis at all, was 0 number of roots. You get the idea. Make sense? So that is how you can actually find the number of roots from the equation itself. These two are opposite sides, plus and minus. Therefore, it will have two roots. So when will it have one root? Can you tell me? If this would have been 0, then the vertex would have been on the x-axis itself, giving just one real root. Okay. So the term real root is very critical. Real roots. There are always imaginary roots. Okay. One real distinct root. Okay, great. So I think these points are absolutely clear. Let's move forward and understand. How do we find the y-intercept? Now, what is y-intercept? Can you tell me, please? What is y-intercept? Well, clearly, if I am sketching my graph, which is kind of like this for us, right? Okay. And we identify that this point vertex was way below the x-axis and y-axis something like this. So that is our vertex, which is 3 minus 8. Y-intercept is where the graph crosses the y-axis. You get the idea. Now clearly at y-axis, what is the x value? X equals to 0. So to find the y-intercept, you have to substitute x equals to 0. Let's do that. So we could write y equals to 2 times 0 minus 3 whole square minus 8. Makes sense, right? Let's calculate 2 times minus 3 square minus 8, which is 2 times 9 minus 8, which is 18 minus 8 or just 10. You get the idea. So I have a y-intercept at 10. Do you see how do we calculate? Substitute x equals to 0 in the given equation. For that matter, in any equation to get the y-intercept. It's a general process. Okay. So we say y-intercept means x equals to 0. Clear? So box it. Remember. Perfect. So that's clear. We got another parameter, y-axis. Now let's look into x-axis, x-intercept. Now x-intercept is not always an integer. It's very difficult to find, right? So let me make it x-intercept. We already found y-intercept. So now let's find the x-intercept. So once again, I'll again sketch the graph. It's very handy to understand and explain. right? Get into this habit of drawing the smooth curve. Oops, that was the axis, right? But we are interested in x and y axis. There you go. And we have also understood that this point here is at 10. And now the vertex is at 3 minus 8. What are we interested in finding? X-intercept means where the graph touches, in that case, just touches or cross x-axis. That is it. So at this point, y is equal to 0. Do you see that? Y is equal to 0 for the x-intercept. So these are the points which we need to figure out. There are two in this particular case we found, two real roots, right? Okay. So it is solving this equation, substituting y equals to 0 in the equation, we get 2 times x minus 3 whole square minus 8. The steps involved, carefully look at them. Bring 8 to this side, so it becomes plus 8 equals to 2 times x minus 3 whole square. Then you divide by 2, right? So we divide by 2 both sides, and we get x minus 3 whole square equals to 4, right? So I'm writing it here. 4 equals to x minus 3 whole square. Now you square root. When you do square root, actually strictly speaking, this value becomes absolute value of x minus 3, right? Now since it is very confusing for students to understand absolute value at this stage, most of them are grade 9, 10 students. So I'm writing plus minus square root of 4 here, right? So that also is an equivalent way of writing, right? So x minus 3 is plus minus square root of 4. You understand? Because if I'm saying that I want 4 as my result, then x minus 3 could be what? Plus 2 or minus 2, right? Both will give you plus 4 when squared. So we get plus minus 2 equals to x minus 3. Make sense? Now what is x? Since we know that x minus 3 is equal to plus or minus 2, x is equal to 3 plus or minus 2. So that gives you two values. Perfect. So you could calculate 3 plus 2 and 3 minus 2. 3 plus 2 being 5 and 3 minus 2 being 1. So we have two roots, one at 5, the other one at 1. You get the idea. And you can check the result, the average of 2, that is 5 plus 1 divided by 2 is indeed 3. So that is the axis. Do you see that? Which is in the center. So it just confirms that your values are perfectly fine. So we do get the x-intercepts, and let me write them, that x-intercept are at, so the coordinate points will be 1, 0 and 5, 0 because the y values are 0. Make sense? As shown here. So we also know what are the x-intercepts. By doing so, straightly speaking, we have already sketched the graph. It's fairly accurate. Perfect. We have the vertex, we have x-intercept and also the y-intercept. So we have the graph, right, from these key parameters. And that's why we say identify key characteristics from quadratic equation and graph. So this rough sketch is now a proper graph for you, which will fetch you full marks. But there is another very important method of graphing which is commonly utilized, and that is using table of values, right? So you must have seen that always we put values in the table and then put those values on the graph paper and plot it, correct? So let me just make, this is my coordinate plane. Since we know how our graph looks like, so I've taken axis like this. Perfect. Now let's go with the calculations. So now the very first question which students will ask is which value to start with, right? So I will say the key value is the vertex, When will this be 0? This is going to be 0 at 3, correct? So 3 is the key value, right? So let me sketch the graph which we already have by now, kind of like this, right? Okay. So what I'm trying to say here is simple as that. We have to start with this value, which is 3. So left side and right side, it is all symmetrical, correct? So we can do one side. For example, if I write value 3 here for x, then I'll substitute 3 for x. I get 2 times 3 minus 3 whole square minus 8. Now 3 minus 3 is 0. When you calculate, you get this left side 0 and land up with minus 8. So you get this vertex which is at 3 minus 8. Makes sense? Now you should go 1 unit on the right. So if I substitute 4, then I get 2 times 4 minus 3 whole square minus 8. Now 4 minus 3 is 1. 1 square is 1. 1 times 2, 2. Minus 8 will give you minus 6. So I have another point here which is at 4, and there the value is minus 6, correct? Then I'll substitute 5 here. And 2, 5 minus 3 whole square minus 8. 5 minus 3 is 2, 2 square is 4, 4 times 2 is 8, 8 minus 8 is 0. So I get the third point, x-intercept, which is at 5. You get the idea. Which we found earlier, right? And now you substitute 6. So we get 2 times 6 minus 3 minus 8. 6 minus 3 is 3. 3 square, 9. 9 times 2, 18. 18 minus 8, 10. So we get a point, I'm writing here, which is at 6, we get 10. You get the idea. Now since we have a graph which has axis symmetry right there, we have symmetrical points. So we have the other point on this side. You can always, correlate, correct? You get the idea? And get other points. If not, you could do your calculations, right? So that is to say that we can go up from 3, right? So from 3 left side this time, 3, 2, 1, 0 and so on. Calculate. So if I substitute 0 here, then I get 2 times 0 minus 3 whole square minus 8, which is 18. 18 minus 8 is 10. And if I substitute 1 here, I get 1 minus 3 whole square minus 8. 1 minus 3 being 2. 2 square 4. 4 times 2 8. And then that gives me 0 as expected. And when I substitute 2, 2 minus 3 is 1. 1 times 2 is 2. And when I take away 2 from 8, I get minus 6. Correct? And then of course I know if I substitute 3 here, I do get minus 8. Makes sense. So what I'm trying to say is only this part is enough, because the other part you could get from the symmetry itself. So I could write this point here as 2 and the y value being minus 6, and this point as 1, and here this is at 10. Makes sense? So we could actually put in all the values in the table by working on one side of the vertex. And then mirror image, right? So mirror image. So basically, work on only this column, which is right side of vertex. You get the idea. It's better. And then do the mirror image to get the left side. So that's the key. Otherwise, you can spend a lot of time in just filling these values. Perfect. So once again, what we did was, we focus on the right side of vertex. So let me write down right of vertex. Our vertex was at 3 minus 8. And therefore, the values taken started with 3, 4, 5, 6. You get the idea. Right side of vertex. So when you do that right side of vertex, let's plot these points this time. We'll do the reverse thing, okay? So there's the graph as we are showing this 2, 4. So this each unit is 2 here. Do you see this? This is 2, this is 4, 6, negative values when you go down, right? Minus 8. And here also we have these units as 2, 4, 6, 8, 10. Do you see that? So these are your values. So if you have to plot 3 minus 8, then 3 is right there in between and 8 there. So you get 3 minus 8. So we have taken this value, 3 minus 8. The coordinate value is 3 minus 8, correct? The next value at 4 is minus 6. So at 4 it is minus 6. And then at 5 we have 0. So at 5 we have a 0. Then at 6 we calculated as 10. So at 6 we have value 10. So this is one side of the parabola. Since you know that the axis of symmetry is right there, right? And therefore, all other points will be mirror image. So you can have a mirror image of these points, right? You see that? So once you have the mirror image, the idea is to join them with a smooth curve. And we'll now sketch a parabola. So parabola is the smooth curve which we are going to connect these points. Name of the curve is parabola. So you see this part is very important. It is like a turning point. Do you see that? And there you go. Look at your points and then sketch your graph. Do you see that? So from here you could come down also. So what you have is smooth curve opens up and with the exact values at labeled. So you can now label it. So this is your axis, correct? Which is x equals to 3. And that point is a vertex, which is 3 minus 8. These are your x-intercepts, right? Which are at x equals to 1 and 5. This one is a y-intercept, which is at 10. And the graph opens, parabola opens up with absolute minimum value of minus 8, right? So minimum minus 8. Makes sense? Domain, all real numbers. And y value being greater than equal to minus 8 as a range, right? So x values belongs to real number. You get it? So that becomes the complete information for the given equation. Are you there with me? Is it all absolutely clear, right? Perfect. I hope you're enjoying, right? It's been a long video. Well, in case you want to learn from me, feel free to send an email. Now, what I wanted to discuss with you is the step function. Step function helps us sketch the graph without calculations, right? So this is very important. Graph using steps. This is without calculation of table values. You understand what I'm saying? So it begins with the basic concept. We have to sketch the graph for y equals to 2 times x minus 3 whole square minus 8, right? So what is 2? 2 is indicating that the graph is stretched by a factor of 2, correct? Which graph? The graph of x square, right? if you compare with y equals to x squared, in that case, this 2 indicates the stretch by 2. Now, normally, if you have y equals to x squared, what is the first difference? The first difference is 1, 3, 5, 7, and so on. These odd numbers. Now, this is stretched by a factor of 2, that means multiplied by 2. And therefore, we say our steps are 2, 6, 10, so on. You'll soon understand what I'm trying to say. So these are the steps from vertex, and the vertex is identified as 3 minus 8. So I'll now tell you how do we put these steps and sketch the graph. So first, as we did last time, we'll identify the vertex. So vertex is at at 3 minus 8 value, correct? So at 3 minus 8 is my vertex. Get the idea. So first point to plot is the vertex itself, which I've done. And now we are looking into our first step, which is step 2. Step like ladder, right? We use step on right and then left. It's kind of a slope gradient. So how do we get that? So if I move 1 unit from here, which will be from, this is 3, right? So from 3 to 4, I have to move up by 2 units. So by 2 units in this scale will be here, because the scale is minus 6 minus 8. Do you understand? And then next time I have to go by 6. So next step I have to go by 6 means 1, 2, 3, 4, 5, 6. There you go. I hit the x-intercept. So we get to 6 steps. You understand? I'll show you how do we go to 10 steps. Next time, step 1 and then go 10. So 1, 2, because each is 2 divisions, right? This is 2 division. 3, 4, 5, 6, 7, 8, 9, 10. Of course, that is 10. So you reach another point. With that, we have already reached our critical points, and you can connect them, correct? And of course, on the left hand side, you have to put the same mirror image. And so you get the left hand side as we did earlier, connected with a smooth curve. Is that clear to you? Do you see, using the step method, actually speaking, we got all our points, including x and y intercepts, without any calculation. Absolutely accurate graph. So was it worth staying so long? Feel free to write your comments and share your views. Still, something more. Watch us. Let us summarize. What did we do? So we finally sketched our graph, which looks something like this. Perfect. Now, the equation tells us a couple of things. Let's review that. If you look from left to right, 2. So that number 2 indicates what? It indicates, since it is positive, graph moving up. So that is one thing. That is what 2. Second, it is also a stretch. We also say narrow. Narrow as compared to y equals to x squared is multiplied by 2. And we also understand this gives you steps. So the steps narrower means 2 times 1, 3, 5, 7. And so on. And that helped us to sketch the graph from the vertex. And we read the vertex from the point, what makes this 0 and what you get after that. So this particular point definitely is the vertex 3 minus 8. So we get the vertex, which is 3 minus 8, critical. And we have also note that there are 2 roots, right? There are 2 real roots. let me introduce one more word, distinct roots. These. And the reason for that is that opposite signs. Which signs are opposite? Coefficient of x is positive and this is negative. Do you see that? So we have vertex below the x-axis and the graph opening up. Makes sense. Below the x-axis, graph opening up, it is going to hit at two places, so we get two signs. So from this equation, we know that the graph is narrow and up with two x-intercepts. Normally, only this information is required. Now, the other thing is increasing, decreasing interval. So you can see very clearly that the graph decreases, right? And then the graph increases. And the critical point to look at is always the vertex. So from minus infinity to 3, it decreases, and then from 3 to infinity, it increases. Perfect. So with that, we know all these parameters. So in a way, you can see that from the graph itself, which we finally got something like this. Let me sketch the graph here now. Beautiful graph. And okay. So we have these critical points, which is 10, 1, 5, and this was 3 minus 8. Perfect. So we found the domain always is all real numbers, range is greater than or equal to minus 5, direction of opening is up, axis of symmetry is at x equals to 3, the vertex is 3 and 8, maximum, minimum, we found this is minimum value as it opens up, decreasing up to 3, increasing after 3, number of real roots are 2. X and Y intercept being at 10, X, two of them, one at 5 and one at 1, and the steps are twice, 1, 3, 5, 7. Make sense? Perfect. Thanks a lot for staying with me so long. I hope you have learned. Feel free to write your comments and suggestions. In case you subscribe to my videos and like them, that'll be great. Looking forward to see you again. Thank you and all the best.